Okay, folks, here we go. Now we're doing topic number 2, which is forming composite functions. And all a composite function is, it's a compound function. It's like a function of a function. So the typical way that we read it is f of g of x. If that's the order anyways, this will be f of g of x. There's alternative notation with a little circle in between, but both mean the same thing. It's both f of g of x. And what does it tell you? It tells you to take the inside function g of x first, and then once you've applied that g of x, then you can apply the f to the result of it. So it's kind of like this little picture here. Let's follow this picture together. So x goes into the g function and spits out g of x, and then that g of x goes into the f function, so you take f of g of x, and that's the result. Okay? Or, I like to think of it as like boxes. This is the g function, this is the f function. So the x goes in here, and what pops out is a g of x, right? And then that g of x goes into there, and what pops out is the f of whatever the g of x was. So for that reason, we call it f of g of x. Let's see, what else do I want to say about this? So you get it by plugging one function to the other. Order of operations follows whatever's closest to the x's first. Okay, so this inside one that happened first, we call that the inside function. Not surprisingly, because if you look at it visually, it's the inside, right? And then the other guy, the f, would be the outside function. And note that we can also compose a function of itself. And you don't have to do f of g, you could do g of f of x. G of f of x, which means you would do the f of x first in that case. Okay, let's try question number 8. Let's try question number 8. Oh, I actually copied and pasted it down here. Okay, so question number 8, we have functions as ordered pairs. So this tells you if I input a -3, then it's going to pop out a positive 1. That will be the output. Here's the input, output, right? X value, Y value. The same for G. So we'll do this one by one. What's f of G of -3? Okay, well, this will be f of whatever G of -3 is. What is G of -3? If I plug in -3, it pops out a 2. So it's going to be f of 2. If I plug in 2, what do I get? If I plug in 2 into f, I get a 0. So the end result will be 0. That's it. Okay, that's this first one. Did that one in red just now. Okay, now we'll do this guy in blue. So G of f of -3. So notice it's both doing it to -3, but we're doing it in a different order this time. This would be G of whatever f of -3 is. If I plug in -3 into f, I get a 1. So that's going to be G of 1. If I plug in 1 into G, I get a 2. So the result is 2 this time. Okay, that's G of f. Okay, let's change colors now. We're going to do f of f. I guess we're doing 2 applications of f. F of 2, which is f of whatever f of 2 is. What is f of 2? If I plug in 2 into f, I pop out a 0. So it's going to be f of 0. What's f of 0? If I plug in a 0, I pop out a 4. So the result is 4. Okay, so that's f of f. And now we're doing 3 in a row. Okay, oh, exciting, exciting. We're doing 3 at a time. Let's use screen color. So I have f of G of f of -3, which is f of G of f of x. And let's make sure I have the right number of parentheses. So first thing is the inside, most inside, right? Is the f of x. F of x, sorry, not x. We know that in particular number here is -3. So f of -3, if I plug in -3, I pop out a 1. So this should be f of G of 1. Okay, so far I just did this part that plugged in as a 1. Okay, now I want G of 1. What's G of 1? If I plug in a 1 for G, I get a 2. So it's going to be f of 2 now. So this G of 1 became a 2. So now f of 2, if I plug in 2 into f, I pop out a 0. So it's going to be 0. That's it. Okay, just kind of getting you guys used to, the the notation, what the notation is saying, what it means. So that's kind of the point of this question, introducing you to the idea of composite functions. So we did that one. We're going to move on to question number 9 next. But before we do that, we're going to go back to the notes. Back to notes. Let me erase all this. That was all question number 8 just now. Now back to the notes. Okay, so we did topic numbers 1 and 2. On to topic number 3. Find the domain of a composite function. Okay, what do the tips say? It says to determine the domain of a composite function such as f of g of x, follow 3 steps. First, look for x in the domain of g. So this is kind of a weird way. It's phrased this way so that it will make sense in the next step. But what this is really saying is just basically find the domain of g. That's what it means. Okay, so find the domain of g, okay? And then, step number 2, look for x where g of x is in the domain of f. So, in other words, for the numbers that are in domain of g, for the x values, which of those result in something that's in the domain of f? So the y values that pop out of the possible range for g, think of the range of g. Where is the range inside of the domain of f? So that's really what it's asking. So where the range of g is in the domain of f. Okay, the domain for the composite function is where the results from steps 1 and 2 intersect. So again, it's that idea of intersection that we kind of saw in the very first video. But this time it's from 2 different spots. It's from number 1, the original domain of g, and then number 2, where the g of x is in the domain of f. Now let's look at some examples to see what we're talking about here. This is number 9 and 10. Sorry to hurt your eyes by all that zooming. Okay, number 9. So this will be our scratch paper here. Okay, so it asks us to find 3 functions: f of g, g of f, h of g. And we're given 3 original functions: f function, g function, and an h function. We're trying to compose them. Starting with f of g. Okay, what is f of g? Well, it's going to take, f takes a square root, right? But g happens first, actually. So first of all, g of x is going to be, and more specifically, I should say f of g of x. F of g of x is, okay, g was a 2x minus 1, right? And f is going to take a square root of whatever the result of that was. So it's going to be a square root of 2x minus 1. That's it. This is my whole answer here. That's f of g. Okay, now for the domain part. Okay, what's the domain? Well, first of all, what's the domain for, remember, g of x? So let's look at g of x. Sorry, different color. Let's do a different color. So g of x, domain. G of x was 2x minus 1. That means domain is going to be anything, right? It could be anything. What about f of x? Fx square root of x, that means you have to be 0 or greater, right? Okay. So amongst the things that are in g of x, right? When do the results from my g of x function, when do those fit into this category? So remember, g of x was 2x minus 1. So when is this guy going to be within this domain? So when is the result of 2x minus 1 bigger than 0, in other words? So for that, I'm going to solve this as a separate equation. 2x minus 1, I need it to be bigger than or equal to 0. Because bigger than or equal to 0, that's the domain for f of x, right? I mean, just looking at it, you kind of know that though, right? Just looking at this resulting composite function, this whole thing underneath has to be bigger than 0. So when does that happen? We'll add 1 to both sides. 2x is bigger than or equal to positive 1. Divide by 2. X is bigger than or equal to 1/2. So those are the things that make this guy 0 or greater. And so now I have the domain for the second. This is step number 2, right? Step number 1 was this part over here, finding the negative infinity to positive infinity. So now where do those things overlap? They overlap at the more restrictive of the two, where x is bigger than or equal to 1/2. So in other words, at this part, from 1/2 onwards to infinity. All that to say now, the domain for this function, this composite function, is going to be 1/2 onwards to infinity. That's the whole thing. Oops. So this is the domain. Okay, that was f of g of x. Let's make ourselves some space now. Oh, shucks, I regret deleting that, actually. But you know what? It's actually good I'm deleting it because it's getting messy there. I'm going to put it on the side instead. Okay? So, next time. Now we're doing, we did f of g just now. We're going to do g of f of x. So that means f of x happens first, meaning you take a square root of x first. And then next you're going to apply g to that. So g takes whatever input, in this case, it was square root of x. It's going to multiply by 2 and then subtract 1. So the result is 2x, 2 square root of x, sorry, minus 1. This is g of f of x. Okay, let's do the same thing. I'm going to do it on the bottom left over here this time. So inside function first, right? F of x, the domain is equal to from 0 onwards, right? F of x is the square root function, so you have to be positive, 0 or greater. Now, what are the results? So if I plug in something in the domain of f, I get the range is going to be always something positive. And then now I'm looking at the g of f of x function. Where's the domain for g of x? G of x, oops, I'm looking at the wrong spot, guys. G of x over here. 2x minus 1. Now, anything that I plug in from the resulting f of x function, any outcome that I plug in is going to be positive. And any of those things could go in here. So actually, the result for g of f of x, which of those values are in the domain? The domain values are going to start from also 0 and end at infinity. Right, so okay, so now where do those things overlap? They overlap, well, they're the same, so overlap would be from 0 to infinity. Okay, now, that's kind of what I expect anyway, right? Just looking at this thing. Look at this thing. What problems am I going to encounter? I'm going to encounter a problem when this x is smaller than 0, and that's it. That's it. You know, as I'm talking to you guys, as I'm saying this all, I feel like it's kind of been roundabout way that we've been doing. I mean, we've been doing it following the correct steps to find the domain, but I kind of feel like you can just look at the function as a whole and figure out the domain from that, right? Although I'm not sure if that's actually kosher now that I think about it. I think you should follow the steps because sometimes in the simplification of a composite function, you lose something along the way. And so it still isn't actually important to do it separately, do it first. So follow the steps I've been doing. Okay, last one. Not last one, but last one for number 9 at least. This is h of g. I'm just trying to think, guys. I think maybe we should cut this after this question because it's kind of going long, yeah. Just trying to think time-wise. The decomposing functions, I think those should go pretty quick. So maybe I should cut this video off soon. Yeah, let's finish up question number 9, and then for question 10, we'll do that in a separate video. Okay, so number 9, last one, h of g. H of g of x, it's going to be it's going to be g applied first, right? That's the inside function. So it's going to be 2x. I'm going to do it in 2 steps this time. I'm taking h of 2x. So h takes whatever I input and squares it. So it's going to be 4x squared, if I square that, right? Or I'm skipping a step here, guys. That's 2x. H takes the input and squares it, which is going to give me 4x squared. Oh, there you go. Okay, this one looks easy actually, because look at the domain range. What's the domain for g of x here? Remember, domain for g of x is everything, because it's just a linear function, 2x minus 1. Now, for the results of when I input something, I could have any output value, right? What is the domain for h of x? Well, it's just x squared is the function that will take anything, negative infinity to positive infinity. So where do those things overlap then? Domain overall is negative infinity to positive infinity. So everything is allowable, and the function h of g of x is just 4x squared. So that's it. Okay, let's cut this video off because it's starting to get long.